Hello, I'm Eric Day with Caringo. I'm one of the product managers here, and I'm going to tell you about some highlights of our S3 protocol implementation that is in our portal. So in the architectural diagram, you saw the multi-tenancy layer. This is in part of that. Let's go to the next one here. So as I said, highlights of S3. I'm not going to teach you all S3 protocol. I'm not going to walk you through the S3 protocol. There's plenty of good documentation that Seattle companies put online for that. What I am going to tell you about is some of the highlights of our implementation of it and differentiators with it. First, with respect to authorization of requests, we support both the bucket level policies and also the per object ACLs, which is the older style, more akin to POSIX style file permissions. We think that both are important. The object style, the per object ACLs are a really special case for older applications. So if you've got an object that just needs to be protected somehow differently, you can put a per object ACL on it. But that's not easy to manage. You've got in your file systems on your laptops, you've got the ability to change the permissions on files on a very granular level, but no one ever uses that because a human can't keep up with that kind of thing. And that's where you need these aggregation units, and that's where bucket level policies in the S3 protocol are important to support that. They can get down to describe a granular level. You can actually, in a policy, describe a very particular object instance. So it's not necessary that you need to go to per object ACLs just to get a special permission on one object in the system. What we do as well, since in our system, and another presentation that we'll talk about, we'll show this off. But in our system, we can have policies at multiple levels. So not just at a bucket level, but at the storage domain level, at a tenant level, and also at a global system level. And so all of these come into play when you're actually melding all these together to make the overall authorization for particular sets of content or objects. It considers multiple levels in the system.
So are you creating a superset of the authorization levels for S3 by doing that?
I would not characterize it as a superset of S3. And the reason I say that is because it's still the same level of policies and it still follows the same rules, and that the policies are merged together and evaluated in exactly the same way as if it had been one gigantic policy that had been at the lower level in the system. And if the lower level in the system didn't have the policy, then it would just be a merger of the upper levels that would be applying down to the lower levels. So giving you more management capability from the top down in that case. So no, I would not characterize it as a superset by any means. It's simply it's an augmentation of it.
Okay.
We also have versioning. And versioning is important in that it's implemented within the core of our Swarm object storage system. Meaning that it's not just through S3 that you get versioning, but also through our native SCSP protocol. And so the same objects in the same versioning is shareable and applies whichever protocol you're coming in through in the system. Also I talked about storage domains in our system. In Amazon, there's 10 what we would call storage domains. There are 10 regions around the world where you can have your buckets exist. When you create a bucket in Amazon, you tell it which region you're creating that bucket within. In our system, we take that concept, except we actually give you the choice of what you name your storage domain. And that's actually the kind of the core of our multi-tenancy there. It's very easy for us to provision storage domains within our system. There's practically no overhead to them. And that actually becomes a namespace where now you've got your own private namespace for the buckets that you create. You're no longer in this shared pool with thousands and thousands of your friends around the world, but you've got your own private storage domain in the system, and you get to name your buckets and protect your content within there in a more natural grouping that we think. So In the S3 protocol, there is a request to get the location of a bucket. And when you call that, it's going to return one of the regions around the world where that bucket lives and was created. It's always going to return you the same thing, because in Amazon, a bucket doesn't move around regions. In our system, we take this same request, and we add some value to it, in that it's actually going to tell you the cluster that bucket got served up from. And Russell was talking about, in another segment, was talking about the data feeds as a way to replicate between multiple locations. This is actually a geographic distribution of the cluster. It's not always the case that you're replicating because you want disaster recovery. You may actually have an active use case where people are reading and writing content from multiple locations. You're geo-load balancing them to where it makes sense. And so get bucket location is going to tell you, I was served from cluster A, whereas somebody else calling it may say, I got that same bucket served from cluster B, because we allow you to replicate your storage domains across different clusters, and that's handled automatically within the system. Also, like Amazon gives you the ability to define your own sets of users that you then use in your access control policies, we also allow you to make use of multiple identity management systems within our storage offering, which means that for companies, a lot of companies that use us use only one identity system. They'll have their Active Directory, their LDAP, and they have all their users and group defined in that. But when you get into larger enterprises, multinational enterprises, or into MSPs, now it becomes very important to start segregating out the sets of users and groups in the system, so that admin in one realm, you can have admin in another realm as well. It depends on the identity management system from which that user is being served up from. And so we do give you the ability to use one or many different identity management systems in our multi-tenancy model. We also support token-based authentication with our S3 protocol. What's important about that is that you as a user can go and pre-allocate or pre-authenticate and get back an access token, and then use that in the configuration and setup of a server or an application that's going to access the system. And you can get a different token for multiple applications or multiple systems. One example I use is that my laptop, I have an S3 app on there. It's got one authentication token, and my desktop at home has a different authentication token. They both relate back to my user account. But if I need to deprovision the laptop, I remove the security token for it, and now the laptop's cut off. And similar, bidirectionally, if my user account is cut off, then those security tokens that were out there allocated on my behalf are now cut off. And so it allows you to, I'm not putting my username and password out around every place where I provisioned applications for access. I'm giving them their own unique token. And this works with the S3 protocol. Okay, so when it comes to implementing a storage protocol for your system, you have choices. We had choices, other vendors have choices as well. And those run along the lines of this. You can either settle for giving the exact functionality that Amazon has chosen to implement in their service offering and no more. You could choose to embrace and extend, whereby you take what Amazon has done as the baseline, and then you make additional protocol verbs or additional options that are passed along with the verbs to do different things in your system. The danger of that being that if a developer starts using some of those extensions on one vendor's implementation, those are not usable then on another vendor's implementation necessarily. Or you could choose to go with parallel paths where both are able to use and manipulate the same set of objects and share objects behind the scenes and have all the same capabilities, in so much as their protocols can express. So if versioning is supported on one, you get to use versioning on the other. If metadata searching is only usable on one of the protocols, and the other protocol doesn't understand it, well, then that's just a feature that other protocol doesn't have. They can still use the same objects that those search results would apply to, but they're not able to express the searching request. And that's what we've done. We've chosen to have our own SCSP protocol and S3. You go back in ancient history now, 10 years ago, and Amazon and Caringo both developed our own object storage protocols out of HTTP 1.1, pretty much in parallel.
So wouldn't we anyway, when you've got protocol support that isn't just all HTTP based, we would have that problem anyway, wouldn't we? Because there'd be things that just aren't built into things like SMB or NFS, where you couldn't necessarily query things to that degree. So it's sort of the case anyway that's you'd always have differences between protocols. You
would always have difference between protocols. I would say though that that's really kind of a different case of translating when you're really going through a very disparate conversion between one access pattern and protocol versus another. If you look down at the two protocols, S3 and SCSP, you say we can do writes, we can do updates. And you say, well, here are the verbs. The verbs almost line up exactly on that. We've got slight dialect differences, really. There, but it's not a big translation like saying you're going from a file-oriented access where you say I want to list a directory, I want to list the subdirectory, I want to see what who the owners of the files are, or I want to see the what are the POSIX style attributes on the file, and I've got to find a way now to try to translate that thing that doesn't exactly exist when you come into a cloud-based storage system. So would differing capabilities exist between multiple protocols? Yes, they always will. The point here was that we wanted to allow you to equally share content no matter what cloud protocol your application is using. So if you've got programmers that are very comfortable with or required to use S3, S3 is not the de facto standard. It's actually the de facto choice of a lot of people. It's an evolving protocol, and we follow what Amazon's doing with it.
So what percentage of your customers use your own protocol, and what percentage will just take S3?
I don't think I've got an exact percentage for you. Most of our customers are making use of the native SCSP.
Really?
Yes. That comes from the application integrations that were talked about when Tony presented. Most of those are done with and we'll have another presentation on our software development support.
Do you think that's representative of the size of customers you have, that they've decided that that's the way they can afford to do it or choose to do it, or is that, because that seems unexpected to the way we're told that the market has gone. We keep getting told that everybody would prefer to use S3 rather than use proprietary, shall we call it.
I think a lot of it is about, if you're at a telecom level, then people that integrate with that are going to integrate through S3. And those are, say, the telecom or the service providers' customers that are downstream. Now, it's an on-prem cluster to the telecom, but those people are on the other side of an MSP. If it's either a single tenant application or an on-premises cluster, many times they'll make the choice to code directly to the REST API, to the lowest level REST API.
And I guess you're going to tell us why in a minute.
Well, it's going to be very high throughput.
Am I jumping ahead? Sorry.
He's going to get right into some more of the reasons why, exactly.
All right, I'll let you carry on, sorry.
Maybe I missed it or not, but can I get access to this data, or can I get NFS or SMB access?
Yes, you can. And
but not necessarily to the namespaces or whatever that I'm creating. If I create a bucket, I can't easily go in and say, I want to share this out. SMB or anything like that, right? Or can you?
There is our FileFly product, which I won't talk about in this one, but a FileFly product is that interface bridge.
Okay, so it's like a gateway or an on-ramp or something like that.
Yeah.
What's a
missed that.
size of a typical customer in petabytes or terabytes. What's an average customer size for one of your solutions today?
Average, I mean, we go as high as, I turned it on. We go as high as Department of Defense, probably has about 16 petabytes provisioned, although you're going to see some health reports that TW is going to show later where they don't phone home for obvious reasons.
Yeah.
But I'd say average is probably between the highs and the lows, sub petabyte,
Really? Okay.
hundreds of terabytes.
Yeah.
So the smaller viable configuration for the system.
The smallest viable configuration for the system, really three disk drives.
Yeah, I'm running it on my laptop.
No, yeah, I know, but usable also because you have 3 drives and then performance sucks.
So I mean, you're
servers
asking
or-
theoretically what's the smallest? It's 3 disk drives. It could be spread across three different
Okay, but
nodes. Yeah.
from the production point of view, no? So
So we say 3 servers generally.
3 servers.
Yeah.
And however many disk drives you want in each one. I mean, 3 1U servers with 4 disks is a completely valid and useful cluster. You can put billions of small objects on it, and it's high performance. And you usually don't want to go lower than that because even in that configuration, you'd be using probably 3 replicas of data protection.
The server is pretty small.
Right.
So
And large at the same time now with
Right.
with
I didn't
large
see
disks.
anything like with respect to access versus storage node personalities. There's nothing like that here, or? I would say there are some competitors out there that have specific personalities for nodes. They're either storage nodes or access nodes or things like that. You guys don't have that sort of.
yeah, we call that more of the control node, where you've got this.
Oh, there is a control node.
Yeah, this coordinator for the cluster, or these localized coordinators, which would be like an access node.
So, but that's a great question. So these core nodes are all load balancing nodes, and they're all data serving nodes.
So they're all actually talking to requesters that are coming in and saying,
They
I
can
want this
service
object or I want to write this
directly.
object.
Absolutely.
Yeah, and Ryan will talk about this later in the software development practices, but literally a cluster is considered flat to us, and that native clients are encouraged to actually talk with all of the nodes to randomly distribute their requests across the whole cluster. And the cluster actually will do the load balancing to send you to the right spots as well. So there are no front end control nodes in the sense that you see others do them.
Yeah, there's no requirement for load balancing infrastructure in front. The cluster will automatically load balance requests.
I want to make sure that I completely answered Chris's question though about what you get from the different protocols, which you'd ask about. So a lot of companies or departments will make the choice that we're going to standardize on S3 because there's people in the market, there are toolkits, it's easier to hire people for that. It gives us some assurance that, if we change platform providers, or if we want to straddle between, actual public cloud and an internal cloud, then we're not trying to rewrite and redo that stuff. And so what do you get from that? Well, what you get with our system is you get the ability to do that. You can, if you want to write S3, write S3. That's great. It's not a second class. It's not a second class storage option. In addition to you writing with S3, if you use the native protocol, you gain some additional features on content that's already usable in use through the S3 protocol. So in parallel, you get the ability to do the metadata searching. You also get the ability I wrote unnamed objects. These are where there are system assigned names when the actual name of the object is not important to the application. You get the life points we're talking about, and you get worm capabilities in the system, which in compliance or in archival cases, that's important.
I know this might seem like a silly question, but I'll ask it anyway. Is there any difference in performance between your own protocol and the implementation of S3 in terms of the way it responds or the way the code is executed? If you were running thousands of requests, would your API work more efficiently on that than S3 would be, or is that a relevant discussion?
It's in many cases it's not an important factor of the overall transaction point. Especially when coming through the multi-tenancy, when using the multi-tenancy parts of it, there's really not going to be a difference there. If you strip out the multi-tenancy stuff and you're plugged straight into this core storage nodes, there's maybe milliseconds worth of difference there.
Okay.
And the reason for that is because, as I said before, if you went down and said, S3 support, uses put to write, and we use post to write, and they use put to update, and we actually use put for an update. So, there's very, very small amounts of translation that has to take place.
Right. Okay. I guess that's why I was asking
Yeah,
whether you were sort of sitting above it, really. Sorry, whether S3 was sitting above you and effectively using your protocol, and therefore whether there was that extra overhead, or whether it was natively, talking.
It's very small, very small.
So I would say there is some additional latency, but you can scale those out horizontally. So the overall throughput is the same.
Okay.
So transaction to transaction, there might be some latency. Also, you're limited by the front end pipe in many cases because those will be probably MSP or telecom situations. So I would say, some latency, but overall throughput you can scale out horizontally.
And I guess the bigger the object you've got, the less impact it has.
That's right.
Because
Yeah, a millisecond or two of overhead for anything, any object, as you get up into megabyte, 500K or above really starts disappearing
becomes
from the
less
equation.
relevant. Yeah.